Okay, so here's version 2. Notice how it starts off exactly the same as version 1. I'm doing a one sample z-test. I have my hypotheses. Notice they're written in words. And the conditions are exactly the same as the last one. So now I'm ready to move on and do the calculations piece. So on this problem, I'm going to compare z to z star. And since my reject zone is of size 0.01 and my alternative hypothesis is greater than, I know that that reject zone all falls on the right. And so I need to look up and see what's the z star for that. And I have a couple of ways I can do that. One is I know that everything to the left then would be 99%. And so I can go look in the table and see what area corresponds, what the z value is for an area of 0.99. Or option B is if I want to use table T or table B and use the bottom, which is the shortcut, if I create the confidence interval, and remember a confidence interval is measured from the center out. Since that interval is symmetric, meaning that this length is equal to the length on the other side, so those are equal, which means then that this piece over here is currently unaccounted for, but I know, again, due to symmetry of the bell, that that area is 0.01 because it matches the stuff on the right. And so now if I've used 0.01 on the right and 0.01 on the left, then the stuff in the middle has to be 98%. So if I go look up the z star for 98%, I find 2.326. And so now I have to decide, where does my particular z fall with respect to that? So 2.73 would definitely fall to the right of that. So that would place my z in the reject zone. So now I'm not comparing the p-value to alpha. Instead, I'm comparing my z against, and I'm going to put the actual value in here, against the z star. So now, since it's greater by this picture than z star, and I'm putting this for clearer communication to the person reading my paper so they'll know that I know what I'm talking about, I have enough evidence to reject the null hypothesis. Again, I must tell the significance level, and therefore I will conclude the mean reading score is greater than or higher than 83.2. So that's version 2.